In exercise 1.5, the first problem is using the functions f and g, we have to find f composite g and g composite f, and also we should check whether f composite g and g composite f are equal. In general, it not be equal. In few cases, it may become equal. We have to check for the following questions. We will do one by one. So, in the first problem, f of x is given as x minus 6 and g of x is given as x squared. First, we will do f composite g of x is equals to, this should be written as f of g of x. First, what we have to do? We have to substitute the value g of x in the given area. G of x is x squared. Now, we have to use the function of f of x. F of x is given as x minus 6. In place of x, we have to substitute this value. So, it will become x squared minus 6. And next, we will find g composite f. G composite f of x is written as g of f of x. So, g of f of x value is x minus 6, and now we have to use the function g of x. G of x is x minus g of x is x squared, so it will become x minus 6 whole square. So, we got the value of f composite g as x squared minus 6 and g composite f as x minus 6 whole square, whereas for this problem f composite g is not equal to g composite f. For the second subdivision, f of x is given as 2 by x and g of x is given as 2x squared minus 1. So, similarly for this problem also we have to find f composite g and g composite f and we should check whether they both are equal. So, first is f composite g of x, which can be written as f of g of x. So, f of g of x value is 2x squared minus 1. Now, we have to use the function f of x. F of x is given as 2 by x. In place of x, we have to substitute this value. This value will become 2 by 2x squared minus 1. Next is we have to find g composite f. G composite f can be written as g of f of x. First, we have to write the function f of x, which is 2 by x. Now, for this, we have to use g of x value is 2x squared minus 1. So, instead of x, we have to substitute 2 by x. 2 into 2 by x squared minus 1. So, 2 into 2 squared is 4 by x squared minus 1. 2 4s are 8 by x squared minus 1. And for this subdivision also, f composite g is not equals to g composite f. In third subdivision, f of x is given as x plus 6 by 3, g of x is equals to 3 minus x. So, we have to find out f composite g of x is equals to f of g of x. We have to use the relation g of x first. So, f of 3 minus x. Now, we have to substitute 3 minus x in place of x in the f of x relation. So, this will become 3 minus x plus 6 by 3. So, 6 plus 3, 9 minus x by 3. Next, we have to find g composite f. G composite f of x is equals to g of f of x. First, we have to use the f of x relation. F of x relation in this problem is x plus 6 by 3, and now we have to use g of x relation and we have to substitute the value of x as x plus 6 minus 3. So, 3 minus of x plus 6 divided by 3, taking LCM, this will become 3 3s are 9 minus x minus 6 divided by 3. 9 minus 6, it is 3 minus x by 3. And in this problem also, f composite g is not equals to g composite f. In the fourth subdivision, f of x value is 3 plus x and g of x value is x minus 4. We will find f composite g and g composite f. F composite g is written as f of g of x and f of g of x value is x minus 4. Now, we have to use the relation f of x. in place of x we have to substitute x minus 4. Therefore 3 plus x minus 4, it will give us x minus 1. Next we have to find G composite f, which can be written as G of f of x. So G of f of x value is 3 plus x, and now we have to use the function g of x, and in place of x we have to substitute 3 plus x. So 3 plus x minus 4, which we will get it as x minus 1, and whereas in this problem f composite g is equal to g composite f. For the next problem, f of x is given as 4x squared minus 1 and g of x is given as 1 plus x. Let us find one by one. F composite g can be written as f of g of x. So f of g of x value is 1 plus x. Now we have to use the function f of x, whereas f of x is 4 into x squared minus 1. In place of x we have to substitute 1 plus x. So the relation will become f of 1 plus x whole square minus 1, and here we have to expand it using the a plus b whole square formula. A plus b whole square is a square plus 2ab plus b square, and what we have here as a value as 1 and b value as x. So we will directly substitute a square is 1 square 1 plus 2 into a into b. 2 into 1 into x will become 2x plus b square value is x square minus 1. So we will simplify 4 plus 8x plus 4x squared minus 1. So we will write it in the highest power of x to the least, 4x squared plus 8x plus 3. Next we will find G composite f. G composite f of x can be written as G of f of x. Value of f of x in this problem is 4 into x squared minus 1. Now we have to use the g of x relation, which is 1 plus x. Therefore we have to substitute in 1 plus x this given relation. 1 plus 4x squared minus 1. Plus 1 minus 1 will get cancelled. 4x squared. In this problem also f composite g is not equals to g composite f. In the second problem, we have to find the value of k such that we are given with the relation f composite g equals to g composite f, and for finding the value of k we have to use these two subdivisions. First subdivision, f of x value is 3x plus 2, g of x value is 6x minus k. We have to use this equation. So we will find one by one. We will first find f composite f. F composite can be written as f of g of x. So f of g of x value is 6x minus k. Now we have to use the relation f of x for this, and x value is 6x minus k. We have to substitute over here. 3 into 6x minus k plus 2, 18x minus 3k plus 2. Next we have to find G composite f. G composite f is G of f of x. F of x is equals to 3x plus 2 in this given problem, and now we have to use g of x function, which is 6x minus k. In place of x we have to substitute 3x plus 2. So 6 into 3x plus 2 minus k. 18x plus 12 minus k. Now by the given equation f composite g is equals to g composite f. F composite g we found it as 18x minus 3k plus 2, and g composite f we found it as 18x plus 12 minus k. So 18x will get cancelled. Remaining is minus 3k. If I bring the k to the other side, it will become plus k, which is equals to 12 minus 2. So minus 2k, which is equals to 10. K equals to minus 10 by 2. K equals to minus 5. And for the second problem, we are given with f of x as 2x minus k and g of x as 4x plus 5. So first we have to find f composite g. F composite g is f of g of x. So g of x value for this problem is 4x plus 5, and now we have to use the function f of x. F of x is 2x minus k. In place of x we have to substitute 4x plus 5. 2 into 4x plus 5 minus k, 8x plus 10 minus k. Next, G composite F can be written as G of f of x. So G of f of x value is 2x minus k. Now we have to use G of x function where it is 4x plus 5. So in place of x we have to substitute 2x minus k. 4 into 2x minus k plus 5, 8x minus 4k plus 5. Now we have to use the relation f composite G is equals to G composite F. F composite G we got it as f composite G is 8x plus 10 minus k and G composite F is 8x minus 4k plus 5. 8x will directly get cancelled. We'll take k to one side. Minus k plus 4k which is equals to 5 minus 10. 3k which is equals to minus 5. Therefore k is equals to minus 5 by 3. In the next problem, f of x is given as 2x minus 1, g of x is given as x plus 1. What we have to do is both f composite g and g composite f will be equals to x, and we have to show that. Given f of x is equals to 2x minus 1, g of x is equals to x plus 1 by 2. First we will find f composite g. F composite g is f of g of x. So f of g of x value is x plus 1 by 2, and using now f of x value, in place of x we have to substitute x plus 1 by 2. So 2 into x plus 1 by 2 minus 1. 2 and 2 will get cancelled. X plus 1 minus 1. Minus 1 and plus 1 will get cancelled. X. Similarly, we will find G composite F. G of f of x. G of f of x is 2x minus 1 and g of x function is x plus 1 by 2. In place of x we have to substitute 2x minus 1 plus 1 by 2. Plus 1 minus 1 will get cancelled. 2x by 2. 2 and 2 will get cancelled. X. So both left hand side and right hand side, that is f composite g and g composite f is x. Hence proved. So in this problem, f of a is given as x square minus 1, g of x is given as x minus 2. We have to find the value of a if g composite f of a is equals to 1. So we have to find the value of a, and also in the given function we are given with a. But whereas f of x is given and g of x is given in terms of x. First we will change this in terms of a. So if I substitute x as a, I will get a square minus 1, and in g of x also if I substitute x as a, I will get a minus 2. So with this we will solve and find the value of a. So g of f of a equals to 1. So this is given to us. So g of f of a value is a squared minus 1, which is equals to 1, and g composite function we have to use is, instead of a we have to use a square minus 1. So a square minus 1 minus 2 which is equals to 1, a square minus 3 equals to 1, a squared equals to 1 plus 3, a squared equals to 4, a equals to plus or minus 2. If we take square to the other side, it will become square root. So in this problem, given as a, b, c is a subset of a natural numbers and a function f is a mapping from a to b, it is defined by f of x is equals to 2x plus 1, and g is a mapping from b to c which is defined by g of x is equals to x squared. We have to find the range of f composite g and g composite f. So it is easy to do. First let us find f composite g of x is equals to f of g of x. So g of x value is given as x square. So next we have to use the function of f. So which is 2x plus 1. In place of x we have to substitute x square. So 2x square plus 1. Now the range of f composite g can be written as, range will be from the set y. So we will represent it as y such that y equals to 2x squared plus 1. For every x is a natural number. Similarly, we will find for G composite f. So, G composite f is equals to G of f of x. G of f of x value is given as 2x plus 1. Now, we have to use the function g of x, which is x square. Therefore, 2x plus 1 whole square. Now, we can write the range of G composite f y such that y equals to 2x plus 1 whole square for every x is a natural number. So, sixth problem is given as f of x is equals to x square minus 1. We have to find f composite f and f composite f composite f. We will do it one by one. F of x is given as x square minus 1. First subdivision is we have to find f composite f. So, which can be written as f of x. So, f of x value is x squared minus 1. Now, we have to use the same function f of x, but instead of x, what will we do? We will substitute x squared minus 1. So, this will become x squared minus 1 the whole squared minus 1. Now, we have to expand this using the a minus b whole square formula. A square minus 2ab plus b square. Value of a is x square and the value of b is 1. We will substitute this directly. X square will become x power 4 if we square again, minus 2 into a into b, 2 into x square into 1 will become minus 2x square plus 1 square 1 minus 1. This and this will get cancelled. X power 4 minus 2x square. Next, second subdivision is we have to find f composite f. This can be written as f of x, which is f of x value is x squared minus 1. Again, we have to substitute f of x square minus 1 in the sense x squared minus 1 the whole square minus 1. We already got this value right in the previous problem. So, we can make use of this. We will substitute x power 4 minus 2x square. Why am I saying is this we have already simplified in the previous subdivision. So, I am going to directly substitute x power 4 minus 2x square. So, f of x power 4 minus 2x squared. Now, we have to use the x value as x power 4 minus 2x square in place of this. So, it will become x power 4 minus 2x square whole square minus 1.